We're going to do a short little bit of math in here, and then we will have 2 sessions, both covering 4th and 5th grade math. One focusing on how we are transitioning students to the standard algorithm, which is the way we learned how to add and subtract. And the other session will focus on how we are transitioning students to the multiplication algorithm. So 4th grade, students learn how the standard addition and subtraction, and in 5th grade, the standard multiplication. So tonight, the question that you will be able to answer is, how do I know that my child is ready to learn these 2 algorithms? Because if you came the other night, or if you know what's been happening, we've been working a lot on strategies. And now we are moving to a very efficient algorithm. And so kind of seeing what that last bridge is to that piece of it. So feel free to ask questions as we go along. The title, well, we'll go back to here. The title was Investigation Discovery, the Modern Math Playbook. Started to think about a playbook and what it has to do with math strategies. Any of our dads didn't give us any information on a football playbook or a football play. That's what I thought about when I saw that. Anything you might want to tell us about what that's about?
Basically what it is, a playbook. You just design certain plays that you think are going to work best in any given game.
Okay, and that is exactly the transition to in math. What is going to work best based on the numbers that I have in my problem? There might be a different strategy depending on the numbers, and I want to think about the numbers just like the football players think about the situation on the field. What's going to work best? It's not just one play. We're always going to run the same thing like we knew. So some kind of things we're thinking of. It's a plan of action. We're going to either try to solve a problem. It's like we said, depending on the situation on the field or the numbers. And it's just a way to communicate. So all of the strategies we've been using and the strategies you see in the playbook are ways that students are communicating their understanding with their classmates and with their teacher. So what brain research has told us is that the left brain and the right brain, when we can connect that numerical piece to a visual, we remember it better. And so that's why we've done a lot of work, K1, 2, 3, now 4 and 5, in getting that visual connected with the numerical. Different parts of the brain light up depending on how we're thinking about a problem. And so that's the brain research that's coming out regarding that. Okay, time to get to work. This is something called a math talk. I wrote the problem up here, 712 minus 298. Our students do a lot of mental math, a way to break numbers apart, put numbers back together. And so I want you to kind of think of this problem without writing it down, see what you can do with it. I won't make anyone give me the answer or do anything like that. But take just a minute. What our students do is they think mentally, they put one finger up if they have one way to solve it. If they can think of a second way to solve it, they put another finger up to indicate to the teacher. They can think of a third different strategy, and then we share ideas. But I'll give you maybe about a couple minutes to just think of how you might solve this problem mentally. We're going to stop it there. Does anyone want to share their strategy with us, or you don't have to?
Do you want me to write?
I don't know. We'll see if anyone wants to share a strategy. Okay, thank you.
I added 2 to 298, subtracted 300, and then added 2.
Okay, so 712, and then you added 2 over here and made this 300.
Yes.
Go ahead.
Then I subtracted the 300 from the 712.
Okay, I'll do it this way. and got
412,
412.
and added 2,
Added 2 back in and got
414.
414. It's a great strategy. What would happen in the classroom then is students who totally did not understand that strategy might be asking different types of questions about that. You know, why are we adding a 2 in? I thought this was a subtraction problem. You know, students would ask different kinds of questions, but this ability to use place value and to break numbers apart and put numbers back together is what we've been doing with our students all the way till now. And I'll share just a few. That's one that our students like to use. That's a great strategy. We'll just go through kind of one. Raquel, this was an interesting one. Kind of broke off. It's almost like thinking about how she needed to break this off. She knew she's going to need 12 to get rid of that 8. So she took the 12 off. She needed then 100 to cover the 90, and then she needed the 600 to cover the hundreds. And so she broke this number into different pieces to have enough to cover all of her different parts. And then as she subtracted and then built the 200 off of the 600, the 90 off of 100, and the 8 off of the 12. So lots of different strategies that students use, and we won't go through all of them because we are going to get onto some things. These were a couple of other ones, but you'll have time to look at some strategies and try some out in a little bit of detail in a little bit. Okay, so we're going to break into 2 groups now that we got everyone seated. We're going to have multiplication starting in this group, and then addition, subtraction, and you know, it's 4th and 5th. Basically in 4th grade, we do a lot with whole number addition, subtraction. 5th grade, that moves into decimals. 4th grade, we start with multiplication. 5th grade, that moves into the traditional algorithm. So I guess we can just split kind of half and half. Half of the people can go next door and start out over there in the library, and then half of us will start here, and we will you know, do maybe about 20, 25 minutes of each group. Okay, so let's take maybe the back half can head next door if that's okay, and we'll leave the front half in here all settled in. And, get you. Good to see you. Okay.
All right, well, we're gonna go right on ahead here talking about multiplication.
Oh, yeah.
So you'll see you have bags on your table. If you could count out 24 tiles for your family. Or yourself.
Pass it on.
Yeah, we have plenty, so you can each have 24.
The what, I'm sorry?
24 of those squares. This would be an example of a manipulative, something that the kids can move around to help understand the operation.
Sometimes they're squares, sometimes they're this.
Yeah, 25.
So each one needs 24?
Yeah,
For this problem,
For
yes.
this is just an example. We're using 24.
Do I pass this on? The sign-in sheet?
Did anyone else need to
Thank you.
sign?
I think
They've signed.
Okay.
Always.
Yeah, we got it?
Did you
Okay.
sign in?
Oh, did not.
Oh, all right. Okay, so as you're finishing up, we just have a real short video. Why Common Core math problems look so weird. So we'll let you.
So math in some ways is like baking, and math used to be taught as a recipe, as a series of steps you do, and then you get a result. And what you understand if you're a cook or a baker is that you add things in certain proportions for a reason, and that, you know, your cake has to have this percentage of fats and this percentage of flour in order to work. And what Common Core tries to do is to do the same thing with math, sort of developing what they call number sense. And number sense is understanding more or less why we do the things we do. Common Core is taught in a way that most people over 20 don't recognize.
We find ourselves tearing out our hair at the new math.
It's the same thing I do when I get a check at a restaurant, draw a bunch of shapes and tell the waitress to find my errors.
Parents taking to Twitter, posting unbelievably complicated homework assignments.
These math problems circulate that just seem really nonsensical, which is really frustrating if you have a kid who has this simple problem that looks like it's being made way too complex for no reason. It's totally understandable why people would say, this recipe that I learned is the quick and easy way to do it. Why aren't they just teaching kids to do that? So for example, we all learned to borrow when we subtracted, but this doesn't really show you what you're doing. It doesn't really show you what borrowing is. And so one of the ways the Common Core tries to explain this is with a number line. Because subtraction is really about finding the distance between two numbers. You start with the number you're subtracting, and you take little hops up to a more round number. So you go 10 between 90 and 100. So you've sort of broken down this distance, and you add these numbers together. There's another method called the counting up method, and this is also for subtraction. Count up from 38 to 40. Then from 40, you want to go up to the next big round number, which is 100. Then you need to go from 100 to 300, and then from 300 to 325. So that's the distance between 38 and 325, are these numbers that I've circled. You get this idea in your head that numbers are flexible things made up of other numbers. 40 is a 38 and a 2. The standard algorithm is the easy and quick way to do it. Students absolutely still have to learn to do it that way. But the idea is that this gives them a better understanding of what they're doing, and that there are a lot of ways to do this. There isn't just one right way to find the solution to a math.
Okay, so using your tile pieces, if you could find a way to show 4 by 6.
I think we already
Not
have
right
it.
now, then.
I don't know how.
You were just doing
Yeah,
that.
there's not a right way here, we're just,
I was just making sure I
That's
had
good,
ready
yeah.
for, so I just.
yeah.
And that's the number sense we're looking for kids to develop.
Oh, okay, yeah, there we, okay, now that we.
One other way, Ed.
Yeah, yeah.
6, 6, 6.
Yes, I want. Got it. Okay.
So it's just the processing that's more important than the outcome? Is that what the Common Core math is like?
It's giving that picture of we want them to definitely be secure with the numbers, but what does that mean when you're saying 4 times 6? What does that mean if you say the area is 4 by 6? So getting that understanding to go along with it. It's being able to picture it. We have some nice variety here, some arrays, a group of 4 6s, and some rectangle arrays. That would be an example when we would call concrete examples, so something tangible, something you can see. This would be a model of 4 by 6. Okay, now in your playbook, if you can go to the page with a small grid, like this. All right, so in this playbook, a representation of 4 by 6 on your grid paper. So how, if the student would be given a grid paper, how would they show 4 by 6 using this? So you can just sketch away in your pencil.
She's copying me.
Yeah.
So now that the students have had a chance to use the concrete model, now we're representing on the grid paper, and we should have our representational where we're showing 4 rows of the 6 tiles put together like this.
And we would transition from actually shading in each square to putting an outline around the squares.
And why do you do that?
We want to ultimately have the students with the understanding that we're going to get to. So
Okay.
if we just go on one slide, I think the
Okay.
answer will appear.
Now, right below in this little space here in our playbook, if you can draw the draw a representation of 4 by 6, just a rectangular area model. Just that outline.
So are we getting to
Yeah.
fractions?
Yeah, and this one can just be the outline.
Oh, just the
not
outline.
not shading it in, only because we've done it, now we're moving on to, you know,
Oh.
just that outline.
So that then, what we want this connection being built to be is that shows the same thing as the 24 separate squares put together, the shading on the grid, and this all show 4 times 6. And the idea is that once students build that knowledge, we can then move away to, okay, 4 times 6 is 24, and they'll just have that knowledge.
Right, so then they're not having to draw, well, it depends, we use the concrete models as much as we need to.
Some
along
draw
with
a
the
lot
graph
longer
paper.
than others.
Right.
It's just the way it is.
So we understand that this 4 by 6 is really, you know, can be represented, our graph paper can be represented with our concrete models.
So it's the idea that when they see this, they can visualize
Exactly.
24 squares and
Right.
they're like.
Exactly.
Right.
And then eventually they don't even need to visualize it anymore. Eventually it becomes internalized that, oh, when I see that, it's telling me it's 4 going one way, 6 going the other.
What would happen, a lot of the kids would think, well, the only thing I'm talking about is this line here and this line here, and they wouldn't know what all this is.
And they want
They
to
would
take out
literally
rulers
say
and
it's just
measure.
there.
And it's really not about measuring, it's about the concept and the representation.
So
Then,
it's like a pattern analysis that
Mhm.
Then we'll use the term, sometimes we'll say number story or story context. What could these numbers be about? So story context for 4 by 6, you can go ahead and write, did you leave a space? Oh, no, we'll think of one. So it could be, you know, it doesn't have to be an area 4 by 6, but some real context for when you would represent something with 4 times 6.
And I don't know about you, but I find often when I ask students to do that, it's seasonal or connected to something else that's going on. So very likely they might say something now like, 4 kids went trick-or-treating, each child got 6 pieces of candy. How many pieces of candy did they have all together? They do make that connection to things happening in their lives. Usually the context they give it has some relevance to something that's happening.
But they're asked to write their own.
Right.
Okay.
And it would also, you could have a picture drawing where, if you look behind me, like a lot of us drew the arrays, but he had 4 groups of 6. So, you know, they might have the kids with the 6 trick-or-treats or 6-pack of water or something and having 4 of those. So they have some connection to meaning with these numbers, with these operations. All right, so then in grade 4, module 3, we start to bring in multiplying a double, triple digit number by a single digit. Okay, so we'll start with the same thing, what's the story context for this problem? What could these numbers be about? Now we have something much bigger. So if you want to think, anybody want to share?
Any ideas? 316 people went to a play at the high school. Each ticket cost $4. How much was the cost for all the people to attend?
So we tend to teach, our first factor would be the groups, and the second would be the number in each group. It's, you know, it's the same whether we hold the, you know, the area either way, it's gonna be the same amount, but we tend to have the first one groups, and then how many in each group. So for like a 4x6 array, it'd be 4 rows with 6 in each row. It's not wrong to turn the, you know, flip it the other way, but that is the common language that we're using. Okay, so then,
Sorry, if it's 4x6, it's how many rows and how many in each?
well, we would, you know,
4 by
either
6
way,
would be 4
yeah, we'd like to say the groups first, and then how many in each group is in our second factor. That's what they would hear more common. But we tell them the area is the same. We'll use our paper 8.5 by 11, whether you, whichever way you point it, this is the same. Then we do a lot of our numbers in operation of base 10, which I'm sure you've seen come home. But to really be thinking about that 316, what does that look like in unit form? So how many hundreds, how many tens, how many ones in 316? And that's how we would move to our area model or tape diagram model with multiplication. That's how we would start to teach it. So then we look down here. So now you have a little diagram in your next playbook after the graph paper. Right here, 316 by 4. So if you want to draw your area, take your tape diagram, and then we'll divide it up, and then we'll see how we're using this area model to help with these bigger digits, because here it's too large for a concrete model. We're not going to do 316 tiles.
No. Usually they'll ask and I'll say something like, okay, you can spend your recess counting them out to get them ready for us. And they decide very quickly they don't want to do that.
But I remember you used something like cubes
Yeah.
and longs, right?
Mm-hmm. We have those too. The
Okay.
base 10 blocks, where you have your flats and your longs and your, yeah, those, that would be a concrete model.
And some
Unifex
students
cubes.
need it and some students
Right.
don't.
And some for longer periods, you know, it's gonna vary with each student. Same progression, different rates. Okay, so then what we end up doing, do we explain it or walk it through? All right, so maybe if we walk it through. Okay, so we think about this area here as 300s. So we would do what are 4 groups of 300s. So what would you have? That's how much is in this tile right here. So then when you finish it out, you end up where, you know, by now the children have been working with these unit forms of the numbers, so they know how many hundreds in 316. So they're multiplying it by our 300s, giving us our 1200, taking our 4, we know there's 110, we get our 40, and then our 6 ones to get our 24. Dividing up the tape. I mean, it's not to scale, but just the idea that the sizes are different.
And we stress that with the kids too. It's not about getting your ruler out and being super exact and making sure that they're truly representing the right size. it's approximate, and we just want the hundreds to be bigger than the tens and the tens to be bigger than the ones.
Right. And then this is not the traditional algorithm. We call this the partial products method, where they're finding the area of this large rectangle by finding the sum of the units and then adding those together to get us our total area for the large rectangle. And again, like Sheila was saying, where we do the right brain and the left brain, we've got our numbers here. Well, now the students can see where these numbers are coming from to help them understand, to help us better remember what we're doing when we're doing multiplication. Oh, this is our, okay, so this is a blown up picture. But when they get to, how many people are in fourth grade and how many are in fifth grade?
Mine's in fifth.
Yours is in fifth, so you've seen this come home? Fifth grade, okay, so, and they'll be getting the double digit. We can talk a little bit about that. But this is the problem set that they'll be coming home with from Eureka Math, and they've got the areas divided up already in the tape diagram. But what we're doing is the same process that we did right here.
And I know it seems redundant when you see it, and it's asking them to complete that and then write the vertical forms. But the reason is we want them making that connection, because we find when the connection is more solid, they make less procedural errors, and they get the correct answer more frequently.
And they have a way to self-check. Because if you're just teaching the algorithm, if they get a number that's way off, they don't have any way to check if it's right or wrong, other than redoing the same thing again to see if they get the same answer. But this way you have an idea about how much it should be. Should it be in the hundreds? Should it be in the thousands? Getting that idea is really helpful for the kids to do that self-reflection. Does this make sense?
For the fifth grade, you'll see the same kind of thing, but the tape diagram will have multiple layers to represent both of the digits. So you'll see that they'll start with a 2-digit by 2-digit, and you'll see tens, ones on the top, and tens, ones on the side as well.
I'm gonna take her math to show them
Yeah.
a double-digit area model. That's coming home, but they're really focusing on that area model. And as they move into the middle school, when you do the distributed property, this all makes sense. Where you're breaking up the units and they're, oh, like this makes sense. And they have this connection to the area model. We can't draw on that board.
No.
Does anybody have any questions? You're all very nice. My friends with kids call me yelling at me, why are you doing it this way?
We're here to answer your questions, so please feel very free if there's anything that you just don't understand that's coming home, or you are wondering if it's coming up. Yes, to answer your question from before, part of the reason that we set them up this way is that when they move to fractional thinking, the groups of idea is already in place. So we can say, what's 2 times a half? Well, we can make that connection for them.
Do you want to try the double digit in that space below, using those
We
same
could.
numbers? Where it says 316 times 4, if right below you want to draw your rectangle and try 316 by 43, just to show us, we can show it in a...
Should we leave this marker?
We had our, oh, this has a
That's
figure
what I
on
wanted.
it.
We could use that. There we go.
Did she take the one? She take use a pencil.
Do a pencil. Or here, a pen.
I could just do it right here on. Do you have a pen? We could do it right here on the.
Kind of show it a little bit.
I'll just show you right here. So if you want your rectangle similar to the, let's go back to our problem here.
And because they've already worked through those kinds of problems, when they get to the 2 digit by 2 digit by 3 digit.
Are tests being adjusted as far as time? Because I know some tests are timed. Are they being adjusted for time? Because it does seem, it makes sense to me. Being done and the way it's being done, but it takes longer.
It depends on what assessment it is.
Okay.
Our district assessments, the things that we do within our classrooms, yes, we
Okay.
can control that. Outside of that, things like park, they factor that in.
Okay.
And on park, it doesn't typically ask them to do both formats.
Oh.
So they'll do the one that they've become most comfortable with, most successful with, and so the time isn't as big a factor.
Okay.
They won't do all 3 versions, they'll just pick the one that they are most secure with. Which is why we give them multiple options, because in the old way of doing it, if all we're teaching is the standard algorithm and we've got a child who's really struggling with it and it doesn't make sense, they have no number concept, they just sink. They look at the problem and they don't have a clue, they pick an answer and move on. But with Park, with them having to actually enter the answer versus just being multiple choice, there's nothing they can put in if they don't have another way to go, they just take a guess. This way, at least they have something else they can try, and they have a better shot at being successful with it.
So park testing is not multiple choice?
Not all. Some answers they have to input the answers, some they have to drop and drag pieces of the answer.
Right.
There's all different formats for answering.
But it's not just the A, B, C,
Nope.
or D?
No.
That's good.
And you really need that paper to show their work, because that's the only way they're going to be able to solve it. You can't, these are not all mental math strategies. So you'll have the piece of paper to draw out or do whatever you're doing, and then you transfer your answer into Park. So you don't get credit for, errors or something like that for some of the things. Anyway, if you drew it out, you would have the same area. Now we're adding this unit of ones. So in 5th grade, you'll start to see the double, the same thing, because now by this point the kids are used to doing this tape diagram. Now we're adding our next unit here because we're still multiplying it by.
And though it seems really foreign to most of us who didn't learn it this way, it makes sense to them.
And it really helps when you get into the middle school, when you do those distributor properties and you're seeing where that's coming from.
So, okay, this has me stumped now. So the 4 tenths and 300, we said that was 1,200, right?
Right, it's like
So then you do 3 ones times.
Because they've gone up to 10s, it would be 12,000.
12,000. Right,
And then 4 tenths times 110 would be 400. And then 4 tenths times 6 ones would be 240.
It's still, no, it's still,
okay. Oh, I got you.
Yeah, I put it in unit form, so you would have it.
Do they just know, like, 4 tenths times 300, they just are automatically see how many zeros are to be there? You know what I mean?
You can put it in standard form. I was following along with this, but you would put your 40 and 3 on the side. So if you were drawing
Okay.
it out, you know,
I gotcha.
the kids
Okay.
would write 40, they'd write 3, then they'd have theirs standard
Okay.
form of what, 316, right?
Yes.
310 and then 6.
Okay. Gotcha. Okay.
So then they can see the zeros, and we've done so much place value work before they get to this point that they understand when you're multiplying those places, the zeros remain.
And it just shows how, like, we're not flexible. with those
Exactly.
numbers.
Right.
Like, you're like 4 tenths and 300s, I'm like.
Exactly.
Yeah.
Ultimately,
Yeah.
they're going to be much more
Yeah.
flexible.
They are more flexible.
Yeah.
I had to, like, think
Yes.
4 tens is 40, like, you know what I mean? And
Right.
they just see tens and hundreds and automatically know.
That
that's
flexibility
thousands.
with it is really important, you know, and then they'll say, one of the questions is 1,400, you know, is 1,400 the same as 1,400, you know, how can that be? And then they'll show you with the place value chart, you know, all that.
And we've asked them what seems like a million times before then. I know it's not actually, but what is 10 times this place? What is 10 times more than this place? So that, yes, they
We
will
have
look
100
at
times more.
Right.
Right.
So, okay.
Right.
Got it.
So it keeps switching on them, and then, you know, you'll give them a subtraction problem, not just the numbers all up. You might say, you know, 36 tens minus, so we keep them.
It does build
Working.
flexibility in thinking. That's different from how we learned.
Yes.
A more exciting way to learn.
Really?
Well, I'll share my own story. As a student, I honestly believed the only way to multiply was to memorize the table, because that was what I was taught. It was drill and kill, and it was over and over and over and over. And I remember like being in a panic that if I didn't memorize this table, I wasn't going to be able to function in math for the rest of my life, kind of thing. When I realized that it was repeated addition with groups of the same size, I'm like, oh, it was like the weight of the world was lifted off of me. But it was far in that process, and I had to figure it out on my own. We're hoping kids don't have to go through so long being afraid, and that they have tools to access it sooner.
And you couldn't picture it. All you could picture was the times
it was.
table.
I just had to memorize them.
You know? And like you knew you were gonna get called on, and that's all you're trying to picture is the
Exactly.
times table, not like this, like groupings
And especially where they are in their math, somebody that's struggling, that story might just really, you may need to just start with that story. What can these numbers possibly be? Because there's so many numbers.
Yeah.
Just to have it make some sense and go from there.
Possibly by the end of your session, I should introduce myself. My name is Maureen Finnegan. I'm an instructional coach at Sword School. I'm Beth Pavlusek. I'm a 4th grade teacher here at Comar. And by the end of this session, we hope that you get an answer to this question. How do I know when my child's ready to use the standard algorithm? The standard algorithm is all the way that we know how to do, you know, adding and subtracting. And it's probably something that you just want to say, why aren't we teaching it just that way? Why can't they just learn to carry the one? We're going to try to explain to you the use of the place value chart and how you'll know when they're ready to use that standard algorithm. So what we're going to ask you to do is play a little game called Bounce. And you have 6 cards in front of you, and with those 6 cards, between you and your partner, if you would just deal out the cards to each other, so that you guys have somewhat of an even amount next between the two of you. If the person that has the first card that says, I have 1, who has the 100, 742 is closest to? Whoever has that card, please put that on the table. That's going to be the first start of your line. So the objective of this game is to answer those questions and and it says the person who has this card will lay it next to the first one. So whoever has the answer to that card is going to lay that next to, and you keep answering the questions until you run out of cards. We're going to let you guys do the rest.
700 who has 800, 700.
Who has the 100?
Are we going that way?
3 more than 540.
So we're just going to make a line of it. Who has the 100? So we're talking about 100.
Rounding at this point.
All right. I just 3 times.
Then you would read.
Oh, okay.
And who has 300
And whoever has the answer to the 700.
Who has 3 more than 5 times?
So it's not necessarily like you can take turns, it's whoever has that card. Yeah.
Who has 20 less
What grade
than
is your
400?
What school are you?
3 tens and 20.
Okay.
He's right now in Cub Scouts.
Oh, good.
This is
Awesome.
the-
Perfect. Yeah, that's good.
Really?
Well,
And who is it?
The initial one was
3
like,
tens and 20. I mean, I have to think about it.
I was here last year.
I was saying,
Yeah,
yeah,
and
and
then
I
you
just
get
think they are going to grow up having more
Are
flexibility.
you going
Well, and that's the point.
Like 3 tens and 20 for what
I didn't
And that's the point of this whole thing is that
music.
we're really
Yeah.
trying so hard to
It's
make
like
them
kind
think
of nice
flexibly with their numbers. Like, what does that mean? 3 tens and 20 are And they can get it right away. Right away here. Just, this is like, well, that's just correct.
Yeah, I did that.
And the mom was like,
Please,
I didn't know that, you know? Okay, we gave you, it looks like everyone is about done. And when I was working with this group over here, they did a great job. And they noticed that that last card, what did you guys notice? And
22 digits, I was looking for the hundreds.
when it said 3 10s and 24 ones, you said you were looking for 3 digits, okay? And then that last card that you got to, it ended up going right back to the first card, and so this ended up being a loop. And so in a normal classroom, we usually play this with anywhere with 3rd, with 4th, with 5th grade classrooms, and this is called number bounce. There's many versions of it, but it's about 35 cards worth. And so you have to really be a good listener when you're playing this game, and it's always in a loop because you'll notice that last card will always attach to that first card.
And so if it doesn't, they know they messed up somewhere. So they have to talk about it. They have to talk about, wait a minute, do each one of these make sense? You can find these online too. They're called loop games, number bounce, loop games.
And you noticed that when you saw the one that said, I have 3 10s and 24, who has 3 10s and 24 ones, you had to stop for a second.
Yeah.
And you said, I was looking for 3 digits, because if you notice, there's 3 digits in that. And that's what most of us would think. And then all of a sudden, you think, what is 24 ones? 24 ones is 2 10s and 4 ones, and now I have to give that back. But because you only had 6 cards, it was a little easier and we made it a little bit less stressful on you. But that's what we're doing with the kids, we're not trying to make it stressful on them, but we're trying to make them really think. And I think I heard that comment is, I really have to think about that one. I think I heard that come from that table, which is a great thing, that we're really making them think flexibly about numbers. And you're gonna notice in this chart, this is the place value chart that we talk about, that you may have seen your children be putting all sorts of dots in. These place value charts it is such a strong tool for us to use, because they're showing 3 10s and 24 ones, and in a little bit we're going to show you what bundling a 10 looks like, and so to show you how the kids are thinking, because they're showing 3 10s and 24 ones, and we're going to go to, I'm just going to run to the next slide because we want to because this is what you may see when the kids are working. Have you guys seen them doing these little dot configurations and showing you the circles and bundling and carrying it over and making a bundle? What ended up happening is they ended up bundling a 10 and bringing it over, bundling a 10 and bringing it over, which ultimately ended up with 5 10s and 4 1s, which is what we ended up with as our answer. Questions on place value charts so far? Okay, we're going to get right into adding. And we're going to ask you to look at this problem, and you can work right off of your place value charts. You guys all have a place value chart. If you don't have a marker, you can just raise your hand. If you don't have a place value chart, we'll get you one. And we have some dry erase markers and little slips that you can write on, the Easy Savers. You want this marker? Use mine.
Here's a couple more.
Oh, what we usually do when we start a big problem like this with the 3-digit plus a 3-digit number is we ask the class what story could go behind a problem like this. Can you guys think of anything or throw it out? What a story context behind these numbers could be?
Real world life.
Anything real world. Anything anyone wants to throw out. Anybody wants to be brave. I always go to money, so.
I always think of apples and mangoes.
Apples and mangoes.
There were 342 people at the concert. 169 people came after the first song, something like that. You know, so big numbers, some were big. There were 342 people at Family Fun Night. 169 more came later. You know, something like that, where they can actually kind of visualize what's happening. Why am I using these numbers? They're not just completely naked numbers, like out of the blue.
If you could, please put 342 using those dots in your place value charts, that would be great. Try to just put those into your place value chart.
You want them to be dots? We need a eraser.
You need a marker or, clean it.
part of it. So this is really foreign to me, so I'm writing 300 down.
No. Okay. You're gonna, if you wanna go to the next slide. I skipped over. That was my fault.
Oh, okay. So you're gonna think I have how many hundreds? I have 300. So then you make, if I have 300, then this is 100.
Hold me out here. I can't
That's
go.
200. Here's 300. Okay. I was thinking in terms of
Yeah, in,
of like a time frame, or, you know, I'm
right,
I was
right.
thinking
No.
of manipulative, since that's what I work with on the sun right now.
Right.
So, okay.
And then.
So in a 10 frame, each dot is 1. Just
Okay.
1, but now here we have to kind of shift our thinking, so it's,
Good job,
which is going to hard, is
Nice
it
job.
10,
Good.
you know, or 100,
Rip up that
depending on
paper.
where,
That's what I say to my
or
kids,
1
no
tenth, or 1,000.
Okay, good job. You get the next slide, yes. So in the star,
Yes.
So right
correct.
underneath
It's just
that,
about
if
the
you
placement
would,
that changes
if you would
it.
add the number 169 underneath that in dots, now make 169 on your chart.
She's doing something.
So we do 2, and then what else? You make 169. So I was doing another one. Right, which makes sense. Yeah.
Well, and as you can tell now, there is going to be some regrouping. But before, when we were taught, it was just carry the 1, right? Well, there's more than 10, so carry the 1. I could never tell you why. Well, it's really because there's more in the ones column that we can use. We can bundle a 10 and carry that 10 over. So now we have this whole thing is a 10, can carry over to be 110. Okay? Then I can count another 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This whole thing here can be bundled and carried over. So now we have not enough hundreds to bundle. We have 1, 2, 3, 4, 5 hundreds. We have 1 10 left and 1 1.
Yeah, and it should say 511. I don't know how, I put that said 711. That's not correct.
Let's go back to that.
It's just an error.
You got too many dots?
Too many dots. No, the dots were right. I don't know what I was thinking when I'm putting the math that goes with it. Beth can show you the math on this, because Liz can show you how to do it with the math. Just to connect it to the algorithm.
Sure. Like the
Yeah,
Mhm.
your standard algorithm, how it connects to your place value chart.
So when I add
Yep.
2 and 9, I have 11. There's my 1. I carried that 1 because I bundled and carried it over.
Before you go on, just there, that 1 ends up being this little guy that's the lonely guy that's left there.
It's not bundled. Here we are again. I have 6 and 4 is class plus 1.
11.
All right, so I'm bundling that 10, carried it over. 3 and 1 is 4, plus 1 is 5.
And in using that make a bundle, that's because when you say I carried the 1 or you forgot to carry the 1, most of the kids might look at you and say, because that doesn't always happen in class a lot. They really do talk about they make a bundle. So those ones at the top are really making a bundle and making a bundle, and it's 1 bundle of 10.
And this conversation that we have around adding is just helping them that much more when they subtract. So when we're saying we don't have enough in the 10s, or we don't have enough in the 1s column, we can say now unbundle or unpack that 100 spot. Unpack or unbundle that 10 spot.
And
That's
then
what
borrow
you're
the one.
borrowing. And you're borrowing 110 or 100.
So you
Okay?
want them to show you where they bundled and moved it over,
Yeah.
right? Because we told our daughter, why are you putting so many ones here when you could just do like 2 10s instead of 24 ones?
But can she show you that bundle of 2 10s and carry them over?
Well, she did, but
Yeah.
like, why are you doing it then? It's just easy. Put 2 dots here and 4 over there. So,
And
okay.
did she
So
ever-
we get it.
and-
Well, we got it at home, you're like, stop doing that.
Yeah, like,
There
why
was
so many
probably-
dots?
There was, and did she, but like Mrs. Wusa said, she had a reason for doing that, or she didn't?
No, she explained it, but
Yeah.
I'm like, why?
That's her flexibility with numbers, though.
Right,
She
no,
can
but it's
explain
good.
that
Yeah, she
now,
explained
yeah.
it.
And she's got that flexible thinking. It's not just, well, this is, I mean, when I was growing up, 24 was just 24. It wasn't tens, it wasn't ones, it was
Right.
24. It was, I couldn't explain that.
Right.
Now they can explain 2 10s and 4 1s make 24, or 1 10 and 14 1s make 24, or they have that flexibility to think about these numbers in all these different ways where we didn't think about it like that.
And what that does is transfer right into, because in fourth grade, it's all whole numbers. So if you have a fourth grader, you're gonna be working with just whole numbers, and the whole numbers are extremely large. Some of our teachers have scaled down, and sometimes they'll give them worksheets that have smaller numbers, because they get 6-digit numbers in adding and subtracting 6-digit numbers from 6-digit numbers in fourth grade. And so you're gonna notice sometimes the teachers will change the numbers out to be like maybe just a 4-digit, because they really need to get a handle on adding 4 digits rather than going into 6 place values just yet. And that's,
And the 0 is really what throws them off too. So we have, you know, I'm giving them a 5-digit number that looks something like this. These zeros throw them off, like where they don't know where to borrow from. But now when they have this idea, this concept of breaking up numbers and borrowing from the 10 spot, borrowing from the 100 spot, they can see, okay, I can break this up, unbundle, and borrow the 10.
and
They're not just crossing off and making it a 4, and crossing off and making it a 9. You know, it's
and we'll show you how a subtraction problem works there, but I just wanted to just briefly, and it's just really just, I'm gonna press the button on the slide. 5th grade is where decimals come in. And the idea that this is just dots on a place value chart, and as long as they know where the 10ths fall and where the 100ths fall, this is just an easy transfer, that it's basically, we're just shifting the numbers on a place value chart. And so on the back side of your sheet is actually one where it shows you where there's decimals. But the idea is we just talk about shifting to the 10th place and to the 100th place. So it's not a big it's just a transfer piece. We're really just
and how many of us, when we learned decimals, thought it's a decimal now? What is that
I don't
dot?
know what that means.
Like I had no idea what it meant. I mean, it's a decimal, a fraction of a number. It was scary to me. It's not scary to them because they know. Well, I'm just going to use my place value chart. I know how to move it over. I know times 10. You know, the number times 10.
Is how they move on that place value chart. So when we go into something with subtraction, and if we even wanted to just say this wasn't subtraction, do you want to show this one on a place value chart? No, not the decimal, without the decimal. No. Just show 613 minus because we have to show that unbundling, or did you want to show the 0?
I want to show the 0.
Okay, we're gonna bypass this slide. And we're just gonna show you a subtraction problem on this one. And if you guys want to watch Ms. Kablusik work through a 3-digit minus 3-digit subtraction problem, because it's interesting to see the unbundling.
Okay, so if I have 504, I'm doing 1, 2, 3, 4, 5. I'm showing my 500s. I have no 10s, but I have 4 1s. Okay, I always start in the 1s column. They know this. Start in the 1s column. I can't take away 8 from here, but I can't borrow from here either. There's nothing to take. I have to borrow from the hundreds. So I take 100s. That makes 10 10s. I unbundled the 100, make it 10 10s. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay? Now I can borrow from the 10s to subtract. So I borrow a 10, carry it over, 10 here. Now I can subtract. 8, I can subtract 8 from here. 1, 2, 3, 4, 5, 6, 7, 8. Here's what I have left over. Okay? subtract 9 from here? 1, 2, 3, 4, 5, 6, 7, 8. Oops. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yes. I can subtract all 9. Can I subtract 1 from here? Yes. So my answer is 300.
You got it. You did it the traditional way, it looks like, right? And the idea with the question that we asked at the very beginning of the session is, how do I know that my child is ready for the regrouping and the unbundling? When they can explain this unbundling, or when they can explain how I bundled and I moved things, that's when they're ready.
Not just by showing you, because a lot of them can show you this, but can you really explain it? Tell me what's happening here. You're borrowing a 10 and unbundling it into 10 ones. Borrowing 100, unbundling it into 10 tens. So can they show you and explain? That's when they're ready automatically for this. Because then they know, I can't take this from this, I can't borrow from here, I need to borrow from here. That makes this a 10. But I can't borrow, or can't subtract, so that makes this a 14. I could do it. I mean, they do this quick then, instead of just borrow, subtract.
So how does that work in the classroom? Okay, so you have your 4th grade classroom, and some kids are ready to do that, some kids aren't. You're not, I mean, you know, we grew up in, this is our curriculum, we're just moving around. We're in chapter 4, now we're in chapter 5, we're just moving along. So are some kids in the classroom doing that borrowing, and some kids aren't ready for that,
Yep.
and they're kind of doing it their own?
They're doing it this way. So some kids are doing it on here, on a place value chart. Some kids are doing it here. The kids that don't understand the place value chart yet are back with me during their win time. So they're what I need time. So we have time built into the day where I can help them with math and literacy individually or as a group. So if I have 6 kids or 4 kids that don't understand it, I'll bring them back to my table at the end of the day and say, okay, we're going to work on this right now.
And that's called win time?
Win time.
What I need is what that is. The one piece though, like when you said in a whole classroom setting, are some kids doing the place value chart, some kids doing the regular algorithm? Absolutely. What happens is, and I heard Mrs. Glusick say this at the last session, is when sometimes the kids say, can I do it with, do I have to do it with all the dots? And by that time, a lot of the times they think, you realize, and they can, you make them do one in front of you, and they really don't need the dots anymore because they really do understand what's happening. That's when they get released and say, no, you don't have to do the dots anymore. But those other children that really don't understand because they're trying to do that, they're trying to do what they remembered, like this was the procedure that I was told to do. They need the dots, so they feel more comfortable and safe in those dots. So they stay in the dots until and then eventually they're like, I don't need to do dots anymore, and then they release from it. So it's kind of like a lot of them like using the dots because they know they're going to get exactly the right answer. But then once they get to that point, they're like, I don't need this. I'm confident. I get this. I used the manipulatives. Now I can go to the numbers. That's what ends up happening.
And even if they can show me, I'm not necessarily all hung up on dots. So sometimes kids are just messy and it just happens and these dots are all over the place and it's too overwhelming for them. So I say, okay, let me use actual physical manipulatives. Let me pull out my cubes, my longs, my flats. Remember those from everyday math, right? So I pull out the cubes and say, okay, we have these cubes. You can trade in 10 cubes to make a long, right? Trade in 10 longs to make a flat. So we're actually using manipulatives instead of the dots. They're showing it to me right on their place value chart, but instead of drawing all this, instead of worrying about how messy it is or how neat it is or whatever, they're showing me on this. Okay, now I see you understand. Do it using the traditional algorithm.
And so the one piece that I think, because you're going to go home and you have these little playbooks that you guys have, but this, if you guys would take somewhere in the notes that you guys have, the top thing here, d123.org/family math, no spaces. This is going to be a site that I think you guys are, if you go to that, tell me when I can click it, because it's linked. I'm going to go click it, so because it is an extremely awesome resource that was created very recently, and I should make this large.
you're going to notice that this came out of tonight. And it says Family Math Playbook, and underneath it is the homework helpers. I'm gonna sit right here and talk with my back to you, I'm sorry. And you're going to see there's kindergarten, there's first grade, and this is the things that they're working on with Eureka Math. That's the program that we're using. And this will give you the HH. Let's go to a fourth grade, and we're in module 1. They're doing, this is the actual module 1. There's some things in there that will help you with lessons, but HH is called homework helpers. And if I click this and open that, down here, what that will do, if you look at the top of their pages, over here it says 4.1, like you'll see their homework that's coming home. This is going to help explain some things that are going on. And this is, I see eyes opening like, oh.
Where was this last year?
So, there was a need for it, so that's why this was created. We saw the need for it, and then Eureka did it. And so, I'm sorry that we.
I
easing the
appreciate
pain now.
it. No.
So this just kind of leads to, and it'll tell you, this was lesson 1. So if they can tell you what lesson they're on, and actually on the sheets and the homework sheets that they give, it'll tell you lesson 5, and you just go to that. So if I went back to this page, this goes through all of the different lessons and modules. And if you notice, like under module 3, there is no homework help yet there. It's because Eureka is still creating it. That's how hot off the presses these are. It's that once they create that, we'll set up that link on there.
The blank worksheets are on here and the homework helper, or just the homework helper?
That's a really good question. I'm going to show you. This is actually just the tip sheet that is already linked up to some of the teachers' websites, but it also is maybe sent home every time they start a module. This is just the tip sheet. The blank sheets are not there on the homework help.
This is attached to my website.
It is.
And when you go to the bottom of this page, because again, this is for Family Math, this was also something created with videos on it. This is called representations, and if you go to, do we have 5th grade parents in here? Okay, let's look at this 5th grade. If you go to that 5th grade spot, this page is filled with different videos and different things like, hey, I don't know what an area model is. They're working with an area model, so I can click on this video and it will take me to all of these different, I can go to these resources to watch a video or to help me understand or to help your child, like say, let's watch this together and see if we understand it any better. And these are some things, and this will keep getting added to as people find, as our facilitators find more things to add to this. But I'm gonna go back. And so these are different things that in 5th grade, you're gonna see things like quotients and divisors and expanded form. Mrs. Latier wanted me to show 4th grade, one thing in 4th grade. It's not letting me go up there. Okay. Here's where that video is. This part right up here is like, you're on, Mrs. Kalusik, what lesson are you on?
We're on module 3 already.
You're on module 3?
Yep.
So grade 4, module 3.
Lesson 2.
Lesson 2. So if you go into this, this will give you module 3
Let's take a look at grade 4, module 3, lesson 2. Multi-digit multiplication and division. Topic A, multiplicative comparison word problem.
So these are just some resources, and that the only place this all can be accessed through is through the Family Math website that we have connected at district. So I'm going to go back to this one and questions, because we do have some surveys that we can pass out.
Mm-hmm.
If you guys have questions or comments, please share some of your thoughts. Thanks.
This is good.
Hopefully you got something out of a little bit more on the place value idea.
Yeah, that's super helpful.
Kind of breaks it down a little.
Mm-hmm.
I know the Common Core is something that it's growing. You know, we have people who love it and people who not so favorable of it, but it's what we have to do.
It really does help them think flexibly about numbers. And that's the whole point of it. It's just helping the children think a little bit outside of the box. This is not just a 2 and a 4. It's a 24. It's a 2 10s, 4 1s. It's a 1 10, 14 1s. I mean, flexible. being flexible with numbers.
Mm-hmm. I think it's great.
Thank you, guys. Again, thanks for
Makes a lot
coming.
more
Grab a
sense.
cookie on
Anybody
your
else
way
have
out.
any other concerns or anything that you need to ask me or?
And you can write that on the sheet
I
and
have a
then.
question, actually. If they're multiplying like 50,000, do they put 50 dots in the thousands, or is there a shortcut?
If
for that?
it's, because it's 50,000s, it would be 5 in the 10,000s, so they'd only put 5
Oh,
dots
okay,
in the
okay.
10,000s. There'd be no dots in the
Okay.
thousands. So, and because that's the same thought that some people, like it is, you're like, how many dots
Yeah,
are?
that's-
And so,
so they
but
just
in
break it
any,
down.
in any place, they have to break it down into each.
They're not
each
drawing more than 10
10.
dots.
Okay.
10 in those places.
Okay, that makes sense.